Hope audio is clear for all the participants.
Hello, Sridhar sir, can you hear me? I can't hear you.
Hello, now it is clear?
Yeah, now, yes, now I can hear you. Yeah.
Okay, okay.
Can I just try to share my screen? I just wanted to double check before we start the session, if that's okay.
Okay, check it.
Mhm. Are you guys able to
Yes, sir.
see my screen?
Yes, sir.
Okay. Yeah, for me it is clear. Yeah, maybe you can tell me when I can proceed. At least I'm unable to see my screen, but I hope at least I'm audible and you guys are able to see me. Am I audible, guys?
Audible?
Yeah. Can you hear me and see me?
Yes. Everything
Okay.
is clear.
Okay. Then should I start?
Before that one, I am
Okay.
welcoming the participants for this today section.
Sure, sir. Sure.
Good morning to the participants for this third section. Today we have Mr. Rohit with us. Now I want to introduce Mr. Rohit to the participants. Mr. Rohit did his BTech degree in mechanical engineering from Jawaharlal Nehru Technological University, Hyderabad. Then he did his master's degree from Germany with specialization design and FEM simulation. Then he has good work experience during his internship related to product development with Airbus Group, Hamburg. Airbus Group is a leading manufacturer related to domestic and defense aeroplanes. It will take up the activities design and manufacturing both.
Yeah.
During his span, he got the experience and he performed the activities related to mechanical design to create 3D designs and specifications of pumps, development of bill of materials for preparation, frequency of pipes to avoid windmilling phenomena, and comparison of results with FEM analysis and result documentation. Then he moved to TE connectivity, Belgium, Germany, and he has good exposure to 3D modeling and simulation of automotive contact terminals. In TE connectivity, he performed many roles. One is project management module as a project manager. Second one, engineering module as a product engineer. Third one, product management module as product manager. Next, he is performing activities related to e-mobility terminal connector projects as a project manager during the training program. Now he is discharging his duties as project manager e-mobility at TE Connectivity Belgium. Then he is taking up many challenging projects related to e-mobility. And he has good exposure related to CAE software, Creo, CATIA, SolidWorks, and ANSYS Workbench. Welcome, Mr. Rohit sir, for accepting our invitation. And students from Lendi Institute of Engineering and Technology also eager to hear your experiences and the challenges related to the design of electric vehicles and troubleshooting problems. What is the scenario across the globe? Then they want to get some solutions for their questions also at the end of the section. Welcome, sir. You can start your section.
Hello all. As Sridhar sir informed, I am Rohit Tariboina. First of all, I would like to thank Sridhar sir for giving me this opportunity to participate in this 1 week international online FDP organization by this mechanical engineering department of the Lendi Institute of Engineering and Technology. Good morning to the faculty and students joining all over via online here. Thank you, Sridhar sir. Thank you for the opportunity. Uh, for me, the topic of today's discussion is regarding the current trends and challenges for the electric vehicles and the hybrid electric vehicle market. For today, for today's talk, I have made the following agenda. Yeah, Sridhar sir has given me a very good introduction about me, but I also prepared a short one-page slide so that I can also give you a short summary of mine that I will provide you on the introduction. And then I will take you guys through the current trends and challenges what we are facing in the EV and hybrid electric vehicle segments, which the main agenda is. And also I made a OEM workflow slides for you guys, for the students, which I thought which could be really helpful for you guys to understand where could be your future job positions or the job structures, how the OEM companies work. Maybe this could be helpful for you guys. So I thought this will be really helpful. So I made this one as well. And then as informed, last one would be a Q&A session. So you can ask me any questions regarding this, my work experiences or my challenges, whatever I had in my project experiences. And as I said, I'm already here in Germany, so I can also share my experiences related to your masters or any higher education related to Germany. That's also fine for me. So moving to the next slide. And also one more short input. So after the session, I will be also sharing this presentation slide to Sridhar sir. So I have given my email and LinkedIn links here. If any of the students would like to reach out to me, you guys can directly reach me via email, or you can find me in LinkedIn. Yeah, this will be for your references.
Okay, thank you very much. Thank you very much.
Okay, so the next one is yeah. Okay, sorry. So I'll just give a very short information regarding the education background which I've done. So I have a bachelor's degree in mechanical engineering. This is in JNTU, Hyderabad. So after doing my bachelor's degree, I worked in this firm Circo, this where I have this client as Google. So I was here for these guys for 2 years. So after my bachelor's in mechanical engineering and worked in an IT firm for 2 years, and then because my main aim of doing my bachelor's was my interest in mechanical engineering field, and then after moving to IT field, somehow I was not having this job satisfaction. So then I thought it would be better for me to have a higher education, because from my beginning I had my interest in mechanical engineering. So then I also chose uh, then I was looking into opportunities of higher degree in masters for mechanical engineering. The options were USA or Germany. At that point of time, my with my whatever information which I had and the research which I've done, I understood that Germany would be the one of the better country for people who are having in a mechanical engineering background. And then I reached to Germany for masters, and then I did my masters in scientific instrumentation. This is also related to mechanical engineering field. That's the reason why I kept it as a mechanical engineering field. And during my masters, as Sridhar sir explained, I did multiple internships and thesis. One of the internship was in Airbus, where I was trying to do where I was working on uh, 3D designing and simulations for pipes and everything for the aircraft. And then I did my master thesis at TE Connectivity, and this will be for FEM simulations for terminal contacts. After doing my master thesis, after completing my master's graduate, TE Connectivity directly hired me after my master's. Since then, I'm working in TE Connectivity. From past 4 years, I'm working as a project manager, basically from mechanical engineering and working as an engineering and product development engineering for 1 and 2 years. Moved into the sales part of the segment where I morely work with the project management team. So this is just overview about my education background and professional experience for your reference, guys. Moving to the next slide. Okay, so for now, first point which I wanted to discuss with you guys is regarding the electric mobility or the electromobility. So electric vehicles may seem like a modern discovery in today's world of combustion engines, yeah, but their history goes back more than 180 years back. The technology is now gaining in popularity for some of the same reasons as it was in the last 180 years ago. Uh, Although the electromobility sounds like a novel concept, I mean, in today's world of the ICE engines, these, as I said, yeah, the first electric car was developed in 1830. When the performances of the batteries was improved in the late 19th century, electric cars began to the speed further. In fact, I'm not sure if you guys have this info. Early in the early half of the 20th century, electric cars were sold better than the internal IC engines because they were quite cheaper, easier to start, and didn't emit any kind of a pollutants than the gasoline cars. But advances in the IC engines, yeah, and then the cheap and the mass production of the oil-powered vehicles put an end to the rise to this electric vehicles. From this development in the battery technologies and the electric drives and the oil prices and the efforts to the climate changes have put to the electric vehicles back into the agenda in the 1990s. So excessive petrol dependency combined with the growing threat of global warming and the pressures of the environment regulations to the internal combustion engines is leading the automotive companies, yeah, to invest more in the current electromobility situation. Although these vehicles, EV electric vehicles, currently make up only, let's say, a small percentage of global automotive sales demand, but the demand is rising. If you see in Germany, more than I can say 190,000 electric cars are newly registered in the year in 2021. This is according to the German Motor Vehicle Transport Association, which means there is an increase of 207% over 2020, and this is the little evidence that we can say that this trend could never slow down from here on. This is what I see as the current scenario with the electric mobility. Because of all these factors, the sales right now for the year 2021, yeah, in comparison to the year 2020, this has been more than 2x times the last year. So moving to the next slide. Uh, Here in the current challenges and in the EV and HEV, EV is basically the electric vehicle and HEV is basically the hybrid electric vehicle. I've combined both them together. So basically the advances, what we see in the battery performance, yeah, these are the things which have actually helped the EVs become the fastest growing segment in the automotive industry in the current years. So taking more than the market share, whatever we have from the IC engines, this has been more or less dominated by the EVs in the EMEA market. Even though despite the improved ranges and the performance of the current EV electric vehicles, the consumers are still concerned, yeah, about the below factors. Even though if you see, even though we have a lot of improvements that have been worked on with the EV, the consumers still have some discrepancies in terms of taking a step forward. The first one being the range, and the second one being the amount of time, charging time, and also the third one being the inadequacy of the charging infrastructures. These are the significant three things which are currently highlighted. So basically, in terms of the range, currently the mass market specific factor, this is the one which is influencing the consumer choices, yeah, for electric vehicles. The energy density of the lithium ion batteries are higher because due to the more amount of materials and designs what we use. The 500-kilometer ranges, the mark has already been exceeded for the current EV vehicles. However, if you can see the Tesla Model S, that can, if I'm not wrong, it can travel up to 600 plus kilometers on one battery charge. Uh, on the other hand, the extending the range of these electric vehicles, yeah, requires more energy to be stored. This again influencing a cost and also sizes and also the weight of the vehicle. Because of this, we see a current issue in terms of the ranges. So that's reason why we have the current situation where we are struggling to increase the ranges of the electric vehicles. And the next critical point, which I also said, was the charging time. So this is also one of the critical potential issue where the customers have different issues with the charging times. Yeah. For now, there are AC charging and DC charging and combination of both, but more or less with the current infrastructure, yeah, you either need to wait for a half an hour or maybe more than 1 hour when you luckily get an infrastructure where you have a direct DC. But if you're having a AC connector charging capacity, yeah, it means that it might take more than 8 hours time for you to charge your full cycle. And because of that, there is a lag and there is a significant negotiation, not negotiation, a negative impact on the customers to move to the EV market, yeah, because of this charging time. The main issue where we have here is regarding the charging time. It generally takes place around more than 8 hours. Yeah, this happens because the current the current household sockets what we have here in EMEA regions, this takes only 2.3 kilowatts of energy. So as a result of that, you need to spend this additional amount of hours. But if at all, if you go forward to a DC charging station, that is where you see significantly more number of kilowatts of power that could be charging place. So because of that, there is a fast charging stations are developed, but this is still much what we can say as a time taking process where still we need some more time to develop. So this is the third point is also interlinked with the same one. This is the infrastructure. So the availability of the charging stations is also one of the significant factor in the decision making for the customers in favor for the electric vehicles. In major cities and also in metropolitans and maybe some less problematic situations, the drivers can travel comfortably with a full battery charge. However, the bigger problem is in the long distance traffic, yeah, where charging stations are not available in sufficient number and density. That's why many people fear that the batteries will empty before they reach their destination. These are the main let's say challenges which more or less every EV market in all over the globes are currently working or facing this issue. So what more or less the OEMs are working on in order to overcome these issues would be to develop, yeah, new battery technologies driven by increasing need of this density and charging performance. So the EV industry, the electric vehicle industry, these guys would like to have the EV ranges to be more than 1,000 kilometers at a single charge, and also to have charging time less than 20 to 30 minutes. So that is the current target, but this will significantly rise from year to the year. So the current scenario, in order to tackle this one, is to we need to overcome these three main challenges. So one of the possibility, yeah, in order to increase high performances, or in order to increase because of the high performances, because you need this higher performances, and these performances cables and everything, they should be also somehow accompanied into the car, such that the packaging, yeah, so that whatever the battery that you are using, it is also lower in weight. As a result, you can also get some higher amount of mileage. And another important factor is the faster charging. Yeah. So as I said, with the current scenario, we take more than 1 hour to have a complete full cycle charge for one EV. With this faster charging technologies, yeah, so where you can pump high amount of current with the high voltage ranges, this will significantly reduce the charging time. This is exactly the same way how you try to charge your phones, but basically for in terms of the thermal management, comparison to a phone to a car are really high. So that's the reason why for the thermal management and reliability and durability, OEMs currently, these guys are currently looking for battery cell combinations, yeah, so that they could improve the thermal performance of these lithium ion batteries, and then gain these additional juices so that they could deliver some additional ranges for these ones. And also one of the another direction which the current OEMs are also involving or also investing is in the battery management systems. So this is where, with the current technologies, where these guys are investing in the battery management systems, where they would like to use the systems inbuilt into the EVs, so that these battery management systems can deliver the correct output of power in a required state, so that you could have an optimum you could have a better usage of the current rather than losing it in midway. So these are the two, let's say, these are the two steps which right now the major OEMs are working on, so that they could tackle this current scenario. But the three challenges which we saw earlier, yeah, it is still the same. But it is a step-by-step process that has to be taken care of. But for now, these are the two directions what majorly most of the EV companies are working on. The next one would be now that I've informed you about, let's say, the major challenges what the EV market is currently facing. Uh, Now I would like to give you information regarding the trends. Even though with the current challenges, whatever we saw in the last slide, we saw there is a significant jump in the EV market comparison to last year. In the picture onto the right, you could see the total EVs. Yeah, so BEV is basically a battery electric vehicle, and PHEV is the plug-in hybrid. Yeah, so this is a source which we took from this EV volume website, where they have compared total market sale what has been done for 2020 and 2021. Even though with the current challenges what we're having, we saw a significant growth. So based on this, right now the current trends are such that the consumers and companies, yeah, and the governments are moving with the increasing speed, yeah, towards the electrification. So now the particular trends and forecasts, this will widespread the electric vehicle adoption in 2022 and beyond. Not only all the automakers, yeah, these guys would like to make the significant percentage of their cars as electric. uh, Companies like Ford, Volkswagen, and Honda, yeah, these guys have already announced a sizable investment in order to accelerate this EV portfolio. Yeah. It is already estimated that automotive industries altogether will invest around 500 billion by 2030 for its EV transmission. And if you see here for VW and Honda and Ford, you already see the amount of investment which has been already allocated with the purchase orders with their for the years 2030 as a target. This has been already allocated for these companies. The remaining is as an assumption which will be coming from the rest of the automotive industry, where they would like to see to have the transition from ICE to the electric vehicles by 2030. And you can also see the Hertz. These guys, they already ordered 100,000 vehicles from Tesla. So they would like to run all their services. The Hertz is basically like a DHL, where they would like to run all their vans via electric. So they already ordered this, or they already ordered for 100,000 vehicles from Tesla, so that they could use it for their business purposes. Due to this order, I think last week, this because of this order in 2021, yeah, the final quarter, Tesla made a trillion market cap. And also for Amazon, Amazon has an alignment with Rivian. So these guys also have ordered 100,000 EVs before Tesla. So the first one being Amazon, and then followed by Hertz. And then we also have GM. These have deals with Walmart, FedEx, and everything. Yeah, these guys deal with these two guys so that they could also have EV trucks and heavy duty electric vehicles. Yeah, so that they could achieve some cost savings and also reduce on the emissions. And one more major step is that governments at all levels are currently increasing the variety of charging infrastructure so that they could support the EV spread absorption. United States already invested around $5 billion, so that, I mean, they would like to invest this 5 billion over a spread of 5 years, so that they could build EV charging stations. Apart from Tesla charging stations, this would be their government charging station, so that this would be sufficient for the upcoming demands for 2030. And also, uh, if you guys, I'm not so sure if you guys are aware, but the lithium-ion battery packs, yeah, from the in the year 2010, the prices were not the prices. You could say it as average cost. Average cost per kilowatt hour in 2010 was $1,200. But the lithium ion battery pack for now, for 2020, the average cost is for the year 2021 is around $132 per kilowatt hour. So this is an impressive and 90% decrease in the prices. So this is very good. Because of this, there will be a decrease in the prices, and also the OEMs can use a benefit, and because of that, they can also offer the cars for a lesser rates. So this electrification trend has considered to be tremendous shift toward the electric vehicles in the mind of public. And even the governments, they are also providing some subsidies until 2030. In Germany, until 2030, all plug-in hybrid vehicles and all the electric vehicles under a tariff rate will have subsidies when you buy them. So you don't need to pay additional taxes onto them, and you will have additional bonuses in reverse when you buy these cars by 2030. So this is the current trends which are ongoing. So with this current trend, the what we could conclude is that for the next generation, yeah, I mean not generation, for the next 2030 or 2040 years, the major markets would be electric. So all these OEMs, all the car companies, automotive companies, all the truck companies are moving in this direction of electrification. So from by the year of 2030, many OEMs, even automotive, any automation companies, all these guys are trying to get carbon neutral. So there are some targets to do that. So they are also planning to invest a lot in this electric vehicle platform so that they could be this carbon neutral. So this is the current trends in EV, what is going on for the next 10 years. Now I would, okay, now I would be moving to, this is a power distribution portfolio. Uh, so now that we discuss the current trends and challenges what we are facing, I wanted to show you guys the current scenario. All we know right now is that we use uh, electric vehicles. Basically, you don't have an engine, IC engine, and you have a battery and you have an electric motor. Apart from these components, yeah, on the figure to the left, you could see how exactly many of our OEMs, they reach out to suppliers like us. So our company is a tier one supplier for VW, BMW, Audi, and Jaguar and Volvo. So if you see the first picture onto the left, there you could see a cross-section view of all the components that we could supply to these OEMs for these electric vehicles. So for them, instead of battery, not only the batteries, even for the motor and the inverter, and also the management systems, and also for the heaters and compressors and everything, for all these things, because there is no IC engine, you need to have a current passing charge going from this charging inlet to the battery and to this component so that you could deliver the power. Because of this reason, you need to have all types of connectors which can be able to satisfy the current customer needs. So right now we have a challenges of customers who do not want to spend too much time for charging the stations. In order to decrease those charging times, yeah, current scenario is that you would like to increase the voltages such that these connectors and terminals can take in all these amounts of loads and passing to the battery and then supply it to the other parts. So onto the bottom is where you can also see uh, a layout how this energy transfer takes place from the charging plug to the battery. So basically, this happens when you get your car to the charging station. So the first one being the charging plug, which is already pre-installed into the charging station, and then you have the charging inlet. So this is where you try to add the charging plug to the inlet. So this is where we come, yeah, from charging inlet, and these are from the charging inlets. We have these terminals, and those terminals are crimped to cables, and these are high-powered cables, yeah, because with the amount of voltage what we are having right now, you need to have these cables also, which can withstand all these higher rating currents. These cables are directly connected to the, yeah, connectors. So these connectors act as an interface between the charging inlet and also the battery direct unit. Yeah. So from the battery unit, and you have the further parts that go directly to the battery. So this is just a schematic diagram to show you how exactly the energy transfer takes place. The reason why I'm sharing you this info is right now, as I said, with these current charging issues, the things from charging plug till battery, all these interlinked connectors, they should be also able to sustain this amount of high temperatures so that we could deliver this high amount of currents at a very short time. So for us, all these connectors which we are working on, these will also be, for us, our challenges is to, we should somehow manage, not somehow, but our goals for the OEMs, yeah, Daimler or VW, they reach out to us and they come and they ask us that, okay, we need a connector, it can satisfy this 1000 volts per 1000 volts voltage, and it should be within a specific size targets of 10 grams, 20 grams, 30 grams, and it should be within this layout. So these kind of descriptions is what we get from the customer. Based on their feedback is what we try to give a design and the possibilities what we could come out of it, and then we go for a quote. So basically, this is the general flow. Now I will go for the next slide where you could see the same picture in detail, where you can see what kind of connectors goes into which location. So the one which are highlighted here in A, B, C, D are the different layouts where we have it here. So you have a motor and it have a DC-DC converter. So when you see its connection between A and A, it means that the motor is connected to this converter using these kind of high voltage connectors. And if you see, there is a charging inlet here, and this charging inlet here is connected to either it. So now there are two possibilities. So both the connectors what we have right now, we have this possibility to connect this through the charging inlet. But we take this final decision based on the customer call. These guys will let us know which interface would fix into this charging inlet. So based on that and based on the amount of features of power capacity what these guys would need, we will try to recommend the connector which satisfies all these things, and then we connect it. So this is the schematic flow what we follow. And for all these layouts and all these things, we have this connectors, and within this connectors, we have this charging sockets and all these plastic moldings and also the seals where we need to produce all these things on a given timeline. So this is how the just skeleton, which I could say the things which we currently working on with the customers for VW and BMW and Volvo. Then I would go forward to the next slide, where I would like to share you a bit more about the product portfolios, where I could tell you more. So basically, in our company TE, we have this department called Hybrid Electric Engineering Team, where we work on. So here we are segregated into four verticals. So all these four connectors, what we see here, are already shown in this sections where there are linked for A to A or A to B and A to C. So the team, the four verticals, what we see here is the connector system and the charging inlet system and the battery products and the relays. So I currently work with the terminals and connector systems, and we have similar project managers who are working for charging inlets, battery products, and relays and everything. So mainly my focus would be to develop. We will be having engineering team and everyone based on the customer feedback on the requirements and the quotation. We will be aligning with the engineering teams to provide this kind of a connectors we design and develop for their needs and then ship it to the customer. And there is also a similar team for charging inlets, where you could see charging inlet for type 1, type 2, uh, and type 2 for CCS. CCS is basically a combined charging system where you have AC and DC together. And there is type 1 AC, which is meaning only a AC converter, AC charging. It means it takes more than 6 hours. So we also design the same kind of charging inlets. We get a bill of materials, and we also get a layout what has to be fixed to the car, and then we develop everything on top of it in alignment with the customer. And then there is also another segment where we have this battery products. So basically, the current is directly going from the charging inlets to these connectors, and these will be directly delivering into the batteries. So for batteries, what we do is we actually have some suppliers who from where we get these battery technologies, and then we produce this connector systems from module to module so that they can connect to each other and then ship it to the customer. And we also have a team who will working on relays and contactors. So basically these are some kind of switches which could stop the current flow. So these are the four segments where in our hybrid electric team we currently work on. So from our company, these would be the products which we work on. And uh, most of the connectors, what you see, which I was sharing you for the high voltage connectors and everything, these are also found in many of the OEMs. Uh, the next slide, which I would like to show you, is regarding the business flow. I think this would be really interesting for most of the students, because this is this is like a short summary, which major OEMs like Volkswagen, Benz, Volvo, and BMW, these guys follow. uh, I felt this would be really important for you guys so you can understand how exactly these OEMs works with us, or maybe we work with our own suppliers, so that you can figure out based on your skill set and based on your interest what could be the targeted job positions, or where could be the field of application where you guys would like to work on, assuming from the mechanical engineering background. So basically, the chart that you see here is for the business flow. Basically, first, there are two ways how we get a business. The first one being we reach out, or we go for markets and we try to sell a product to a customer. That is point one. And point two is when the customer directly reach out to us because we've already been working with them. So they ask for some support, maybe for a connector or a charging inlet, whatever they would based on their requirements, and they come to us. So these are the two ways where we try to get business. The main structure, what is you can see here, is the first one being the opportunity champion. So for you guys in the future, the main thing would be if you would like to be in core mechanical engineering roles, the roles would be in procurement, quality, manufacturing, and engineering. Yeah. For finance, you need a finance background persons. For opportunity champions and project manager roles, you would need a guy who has an engineering degree and also having a degree with business, or maybe you can work for 4 or 5 years as an engineering guy and then move into project management or product management or sales. So the structure, the reason why I'm telling you is the main guy in order to get a business would be the opportunity champion. The roles are account managers or product managers. So these guys are the main ones who are directly in contact with the OEMs. So they reach out with our current product portfolios and they have an alignment with the OEM customers and inform what exactly we can offer and what are our specialties. Or maybe they reach out to the sub, or the customer reaches out to the account manager or product managers with their own requirement and then ask for a timing by when we can provide. So these guys are the main ones in order to get a business. So these account managers and product managers are the will be the first ones as acting as a voice of customer. So they collect what exactly the customer requirements are, product requirements in terms of timing and everything. So this would be the first point of contact. Once you have this information, either an account manager or product manager, this varies from company to company, but more or less the roles would be the same. These guys, what they do is after having this information, they reach out to the project manager and also core team stakeholders. Core team stakeholders is nothing but you have a major lead from each individual resource unit. For example, from finance, you have one main finance resource. From engineering, you will be having a main engineering resource. From manufacturing, quality, and procurement. So first initial kickoff meeting would be done by a project manager with the help of account manager and all the higher authorities from all these departments. In this initial kickoff meetings, the opportunity champion, he provides the whole team what is the customer requirement, their targets and everything. In this requirements, we discuss with finance, engineering, manufacturing in terms of all their possibilities or their constraints, whatever we see, and we analyze if we can manage this thing in the given time frames. Yeah, they will give us a timing whether it will be done in 5 years or 2 years or 3 years timing. So initial stage would be here. Once in the first initial core team meeting, we see that we can figure out with our expertise saying that the timing and whatever the engineering resources what we have, and also the manufacturing capacities in terms of producing and producing some lines and everything, and also the quality standards that we need to follow from quality guys. And procurement team will also be joining if at all, if we need to reach out to any other our sub suppliers who could help us to provide some internal parts. Initial kickoff meetings will be taken care by project manager with help of all these core team stakeholders. Once the core team stakeholders, project managers, and also the account managers agrees to the scenario, then we will be having a project kickoff, and then you will be having engineering people joining the project, manufacturing people joining the project, and quality and procurement, and then we start the procedure. Yeah, this would be a business flow how most of the OEMs will follow. The reason for me, as I said, was when I did my masters and when I did my engineering, I did not have this kind of information. So I thought because I was good at engineering, I thought of I will be being only here. But with the mechanical engineering background, we have other opportunities as well. You could also be as an engineering resource. You could also focus on production and manufacturing. If you are interested in quality, there is also a stream there, and also for procurement. If you are if we are much more interested into the sales, yeah, even the sales team for opportunity champions and project management is also really good, because these are the ones who understand what are the current market trends are, what could be the next future trend, how much would be the customer expectations. Based on their feedback, the rest of the team will work on. So this is a general business flow. What is happening at the OEM markets from VW, Benz, and major OEMs. There could be some changes from any other company, but this is just an overview for you guys to understand where you can see and where you can fit into the roles. And then I have another slide where we call it as lean PD process. When this is also one more major important steps where all these OEM follow. One, when you get a when account manager or a product manager, he discusses with the company, and we have our initial kickoff. And once we have an initial update confirmation from also the customer, we develop this project. So in order to develop a project, we follow lean PD techniques. This could be a waterfall technique. Waterfall technique, it means basically you need to go a step by step process. We have 6 stages. This would be also in line with the customer requirement. You can only go from, you have phases G0, G1 to G6. So definition means this is the initial phase where the account manager or the product manager gets the business for us. And then in the concept phase is where you try to design some initial concepts for the customer, and then you take their feedback. The next phase, when the customer agrees, would be the final design phase, where you have your final designs to be locked and everything with the customer. Once the final design is done, then it would be a validation stage. This is where you actually manufacture your tools, build your lines, produce some samples, and do some first of trial parts, and then move to the industrialization phase. Yeah, industrialization phase is where you need to, your product, whatever the product that you have developed, you need to perform some validation tests. There are some IP14 water tightness test. It has to sustain heat test, and it also has some mating forces tests. All these tests, these are already predefined by customer. Once you have your final product ready, you need to go this test, and you need to have a valid test report, and you need to pass all those tests. Once you're done with those valid test reports and everything, then you can directly go for the production. So, and the major point which I also like to highlight is the customer milestones. So when we get this business, when a customer nominates us that they would like to manufacture this high voltage connector, they give us this timings. They give us that they would like to have some B samples. B samples is nothing but they would like to see some prototype samples with the initial designs, so that they could do their own tests. You will get a target milestone for B samples saying that, let's say in calendar week 20, in year 2023 March, we need 1,000 pieces of B samples, and they will give us a deadline saying that we need to log the design in June. And then they'll also give us a major the locking of the design freeze is one of the major factor, crucial. Once the design or the concept has been locked, there is no way that we could change it. So that's the reason why the design freeze concept is to be having a signed documentation with the customer is needed. Once this is done, then we produce those parts. For the initial parts, they would like to have some C samples. C samples is basically the first parts which we produce in our serial line, and then when we ship it to the customer and they say it okay or not. If they would like to do some corrections in the production, then they will try to update them. And then once we are clear, then we do the industrialization phases where we perform all those tests which these guys would require us to do. And once the validation report is done, they'll say that SOP is start of production. So this is where then they would like to have the serial part ready working, and they would like to ship it to the customer so that they could use these connectors inside their car. So these are some major inputs what we get when we start a project. Based on this milestones, and based on the requirements in terms of the parameters for this connector, we have this kickoff meetings in alignment with all the major stakeholders from engineering, manufacturing, and quality and procurement. Once we have this kickoff meeting, whether we can go for this project or not, and in terms of budget and everything, then we take forward. If we see any discrepancies in terms of timing or anything, then we will have a follow-up sessions with customer in order to negotiate timing and then take it forward. So this is a general business flow which happens with any most of the OEMs in the mechanical sector. And this would be these would be the milestones that you would be asked by the customer when you start these projects, whether it could be a connector or whether it could be a sealing or anything. But these would be the major milestones that you also need to consider. Maybe there would be some changes for different customer, but these are the main ones where these guys would be looking in. So this would be important for you. So for me, this slide would be really helpful because I assume that more or less you guys are now at the either in third year or fourth year of your bachelor studies. So if you would like to look forward, you have the possibilities if you are going directly to a mechanical OEM where exactly your interest lies on. If you are a guy who are totally interested in production, you could be having this role in manufacturing side, so you know what kind of responsibilities to be done. If you are interested in quality, you know what is the you need to have your quality VDA test. In Germany it is called VDA test. In India you will be having your own quality standards, ISO standards, that you need to update on. If you are in with procurement side, you can deal with the suppliers in terms of nominating your own suppliers. You can rate suppliers with some bidding overview and everything. So this gives you a better overview to understand where you could fit in your future when you would be working with an OEMs directly. So this for me is the major overview for me to provide you this updated info. uh, for now, I am done. But if you guys have any other questions in the previous slides or anything, I am open for questions. It's up to you guys now. Caesar sir, I'm open for questions or any queries.
Thank you very much.
Yeah.
Some of the participants they post their questions in the chat
Okay.
box.
Okay.
One
Please
is
give me.
Mr. Rajendra Mohanty. His query is, what are the limitations to implement a EV in India? Why delay occurred? Is it possible to compete with other countries?
Okay, so whatever the information in terms of challenges and the trends which have given shared you are earlier with the EMEA market. Uh, for the I'm for the Indian market, probably this would be also the same, but in terms of infrastructure for the charging stations and everything, in EMEA regions, we are already in phase two phases. Uh, However, but I don't think it is the same with India. I think we are really in the nascent phases, so maybe we might need another 2 to 3 years of time in order to move on to the next phases. So the charging infrastructure will be the same, and also the charging times, whatever we are currently going, it is still the same issue. It is whether it is EMEA or USA, it is still the same. So these are the main factors which are stopping the customers to go forward to buy into EVs, and the OEMs, they would like to invest more in the infrastructure so that they could have these EV facilities to get it done.
Thank you. Next query is from Ms. K. Yamuna.
Okay.
Our query is any provision for stabilized power input to charging battery?
Yeah,
How
so basically we have battery management systems. So this is what you will find inside this EV. If when you directly connect your charging port, your charging inlet to the charging input, we directly won't connect it to the battery. We connect them via these DC-DC converters and all those things, where these converters and battery management systems, they stabilize the power and send the same amount of output to the battery so that there won't be any fluctuations.
Then the same question, how it work for different inputs from various charging inputs?
I'm assuming probably for type 1, type 2, GD, AC. For type 1 is AC current. Yeah. So basically, this is where you can plug in into your household plug, and then you give it to your charger. But the amount of voltage that you get from your household will be very less. So that's the reason why you need more than 8 to 10 hours to charge. And you need to see the type of connector that we have it in India. There are type 2, which is a combination of AC and DC together. So it means you can charge your cars directly from home, or if you have an infrastructure, if you have a charging facility, there is a DC charging where you can get it through 2 to 3 hours. So the charging inlet, what we design is a combination of both these two. So that's the reason why you can have both the facilities equipped with AC charging and DC charging together.
Next query is from Dr. Charu Kamesha. Is it possible to design a single vehicle with alternative option, electrical, fuel, and solar? That is,
I think
his question is, please. His question is, design a vehicle. Is it possible to design a vehicle with different power inputs, electric power, fuel, and solar?
So basically, right now we already have the plug-in hybrids. Plug-in hybrids is basically a combination of electric and fuel together. So now on top of that, if you would like to have a solar, so now the current scenario is that technically it is possible to add also a solar power input so that you could charge your batteries, but the only issue would be in terms of the location where you would like to input it. Probably this could be on top of your roofs. There are already some wireless technologies where we can see on your wind screens where you could try to take some power directly from solar, but these are very less. We can't really run it right now, but in future for sure.
And in the same question, one more is, what about the planning related to the manufacturing companies to modify the present vehicles into electric vehicles? Is there any proposal from the company point of view?
More currents, I can't. This could be a generalized answer. The reason being is all these OEMs right now are they are looking forward for the EV vehicles. So most of these investments, what these guys are investing, are on the new vehicles. So I see there would be very less amount of influence on these OEMs who would like to input their money on the already sold vehicles so that they would like to convert it to a hybrid. So there would be, I think there would be amount of cost that you need to do will be really high. So that's the reason why probably these OEMs won't be going in this direction. They would be doing in a new car totally, but they won't be opting it to modify a already sold car.
Thank you very much. Next query is from Dr. Rajendra. Is there any battery waste management system planning by the companies?
Yeah, so as I already informed, more battery management systems are already in the current EV markets. So these are the ones which regulate all the powers, and they will be segregating it to their front motors or back motors based on the amount of need which you choose, whether if you would using a four-wheel drive or two-wheel drive. So they're already in place.
Whether the concept is incorporating at the charging stations, is
No,
waste management is charging stations.
no, battery management systems. These are inside the EVs, inside the cars itself.
Yes. At charging stations,
Mhm.
is there any plan? Is there any plan to take up this activity?
Probably this could be the future. This is the reason being is if you already have a battery management system outside of a EV, instead of having it inside the car, basically you will be saving more amount of space. But the issue what we see is it would be a combination of both. But if at all, the battery management system should be only removed out of the car when the infrastructure has been totally developed. So for right now, with the current infrastructure, the waste management systems are within the car. So that's reason why there would be another additional investment taken care. But once we have a infrastructure totally developed, probably then you could see having the system beside your charging input. So for the current trend, it would be in the car, but later on it will be switched.
Okay, thank you. Next query is from Mr. Prashant Nigam.
Mhm.
Uh, as every system is non-linear, what adaptive control methods is available to overcome the challenge of electric vehicles?
I did not understand the question. I mean, what does he mean by non-linear? I mean, fluctuations in the current
Fluctuations.
or
Yes.
so so the battery, I can't explain more in detail about the battery management systems, but these BMS are basically used to control these fluctuations when you have this transfer. Yeah, basically, for example, in type 2 AC DC, you can have a possibility to charge AC and DC together. So basically, in order to do that, probably we will be using this battery management systems to control it.
Mr. Nitin, his question is EV batteries can be reused for energy storage.
I mean, you want to remove the lithium ion battery from the car and you reuse it?
Battery recycling. EV
So
batteries.
basically, the lithium ion batteries have this time span of some 100 years or so. Once that is done, we can't reuse it.
Can you give some information related to comparison of H2SO4 batteries and lithium ion batteries?
Sorry, unfortunately not. Maybe I
Uh,
could check and give an update, but at least for now, no, sorry.
Next from Mr. Srinivas.
Mhm.
Uh, we are hearing that some problems related to electric vehicles while moving to the hilly areas. How companies are taking care about this issue?
Okay, maybe it would be better if I know what exactly the problem is, because for now, with whether it is in a hilly area or whether it is in a cold environmental conditions, I think these are tested. As informed in the project stages, yeah, in the validation step is where we have a requirement where we need to perform some tests. This would be in terms of height, this would be in terms of pressure, this would be in terms of temperature. So before a car is rolling out, you have all these validation tests performed. Once these validations are succeeded, that is when you have a series car out. So these all these tests are pre-performed, and based on the results is what you get it out. So maybe if you can say precisely what kind of an issue, probably we can answer. But for the now, for the current moment, we conduct all these kind of tests, crash tests, and everything, and then we get the series car out.
Okay, thank you. And next question is Ms. Bindu.
Mhm.
We are hearing that many issues related to blasting of batteries while charging, and some of the bikes also facing same difficulty. while running, some explosion is going on.
Mhm.
And recently also in one of the showroom at Hyderabad also we heard the same news.
Mhm.
Can
Uh,
you give me some of the reasons and troubleshooting and what the companies are looking in this direction to rectify the problem?
So basically, this depends upon the quality standards what these OEMs are working on. So at least in terms of automotive manufacturers, they have a really high quality standards that they would like to run these cars before selling out to customers for more than 1,000 hours in high temperatures and in cold weathers. And they also have the connectors which can withstand this kind of temperature changes as a prerequisite when you order these cables. So this is varies from a customer to customer. For I assume these questions would be for this newly coming cars, two-wheeler cars. The probability could be in terms of the suppliers what these guys have chosen for cable suppliers and also connectors. If they do not have, probably they might have not passed a full series run. So basically, for a car, in order to come out of a series, there are a thousand number of hours as a requirement that it has to sustain. This might be a let's say a factor for these companies. Maybe they have a lesser number of durations. Because of that, they see a high burning rates. So the main suggestion would be, or direction where these guys would like to do is, they would be improving their quality standards in before rolling out to the series part. They will be having many more series of validation tests for temperature and change of weather and pressure and everything. So probably in the coming next year market, in maybe in next fiscal year to 2023 or 2024, the upcoming scooters or whatever, they need to have this kind of a validation test which sustain this ISI standard for India or for US car, for Germany, all those things. So yeah, that would be my answer.
Thank you very much for your patience to answer this question. And next one is by Mr. Rituraj Chandrakar. He want to get some information from you related to comparison of batteries at public charging stations and charging at home, related to cost aspects and safety aspects, and rate of charging, time duration for charging.
So the cost, I think I'm unaware of the Indian market right now, how much is the price. At least from EMEA region, the amount of price that you pay, whether you charge it in your house, in comparison to the direct charging, you have a 20% top up because it is fast. The difference is very negligible. But in terms of timing, as I informed earlier, because of the DC-DC charging where we have this higher voltage capacities at the charging stations, the charging can be done within 1 hour or 2 hours in EMEA. When comparison to the charging that you do it at your house, it might be to 6 to 8 hours because it is a AC connector, because they might only charge very less number of volts per second.
Thank you. Next one is by Mr. Ajay Varekar.
Mhm.
A swappable battery will be implemented in future to save the time. Is there any proposal?
So in terms of this swappable battery concepts, this will make sense if you would use it in the scooter, or if you might use it in kind of a portable transports. Maybe if you would like to use as normal, this would make sense over here. But if you would like to use this swappable transfer in an automotive market, it doesn't make sense. The reason being, right now we were struggling to get this electric vehicle infrastructure. So now we are improving there. If at all, if you would like to use the swappable battery now, then there is another again investment to have this infrastructure already enabled. Because we already started with this EU with the charging infrastructure and everything, it doesn't make sense to again have a swappable battery for a cars. It will be better if we use it for a small scooter or something like that, for sure, but not for autos, cars or trucks, for sure, no.
Thank you. Next one is by Mr. Abhinay Bhatt from Ahmedabad. His question is, as per Indian marketing conditions, the companies are stating that the bike or scooter can run for 45 kilometers once it is charged, and the charging time is 4 hours.
Mhm,
And speed also limited to 40 kilometers.
mhm.
What about the scenario at Germany, and what are the specifications given by the manufacturers there?
Uh, 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 so right now I think in Indian market is where we see this new boom of Ola scooters and everything. For now in EMEA, we do not have like these scooters where we say as Ola, but you can also more of the electric systems what we have here are for trucks, cars, heavy duty vehicles, forks, and cranes and all those things is where you see. But right now, we do not have any OEM with a serious product out. Probably they might be, but for now there are none. And I
Okay.
assume because comparison to the this is just an assumption with the current EV trend with Germany and USA, we see a charging time which is less and already developed infrastructure here. Probably even though if a scooter were to be launched in Germany, probably will also have to face manage the same EU German automotive standards. So the charging time comparatively could be lesser, but not significantly huge.
Okay, thank you. Next one is by Rajat Yadav. Aerodynamic force and thrust in vehicle for charging during moving the vehicle.
You don't move your vehicle while you charge. So when you charge, it
Hmm.
is in stationary position. So no need of aerodynamics there. So
Okay, thank you. Next one by Mr. Vinod Kumar.
mhm.
What are the actions can be taken to implement EVs in major cities like New Delhi to dissipate rapidly EVs in respect to various aspects of factors like IC engines, cost and traffic congestion?
So right now, what we have in Germany is that from government point of view, we have until 2030 and 2035, any electric vehicle or a plug-in hybrid vehicle that you buy, you have a subsidy and you pay very less amount of money than a same car in combustion in respect to a combustion engine. If cities like Delhi and all these metropolitan cities and the government might, if these guys also implement the same kind of strategies, so that if you by giving these subsidies, people will be interested to buying this so that they could reduce the carbon footprint. From government would be the first, and second one, rather than depending on the private sector to build EV charging facilities, government should also take responsibility to build some of the EV charging facilities on their own. So by doing these two steps as a fundamental, you will be basically telling people that we have the infrastructure and we have the cost reduction. So because of these two aspects, people will be also willing to invest their money on this EV platform.
Thank you. Next one is by Mr. Srikar. Whether companies are planning for wireless charging while driving the EVs on the road. Is there any
So
research or any thoughts in that aspect?
So we already have some conversations with major OEMs like Volkswagen and Daimler Benz, where these guys are looking into the current scenario of charging the car from the bottom via wireless technologies. So I can't give you much more detail, but the research in order to transfer the power wirelessly is been started from the year 2017. The major obstacle what these guys currently facing is first thing the same as the infrastructure, but the higher amount of load or the current that you need to transfer. Yeah, if at all if it is a wireless, it would be the time taking will be much more higher in comparison to a direct transfer. So this is a place where we need some more time in terms of technology to deliver this wireless amount of power that you need to transfer from wirelessly should also increase. This is where currently the research is ongoing so that you could develop a technology where you could compete with current amount of transfer rate with the current fast charging technologies. From my knowledge, we do not have any product produced vehicle out, but the technologies are ongoing for sure from 2017.
Thank you. Next one is by Ms. Smita Singh. Sir, whether we are using any fuzzy controller in EVs for energy management at charging stations.
I'm
For
not
energy
sure
management
what do
purpose.
they mean by fuzzy controllers. If they are aiming about battery management systems, for sure, yes.
Mostly it may be like that. Energy management is
Yeah,
stated.
it should be battery management BMS. So we already have it. So for example, maybe for Tesla, if you would like to charge with DC and AC, you can change in the system itself, in the infrastructure itself.
Okay, thank you very much, Mr. Rohit, for your patience answering the questions.
My pleasure.
Thank you very much for spending the valuable time. Dear participants, Mr. Rohit sir has shared his knowledge and experiences with us related to e-mobility, present challenges related with electrical vehicles, and trends related to the development of electrical vehicles, and present scenario across the globe. What are the activities of the companies? And he integrated activities also across the globe, what is going on now. And particularly, he explained the battery management system and shared his experiences related to it. Hope this section is fruitful for all the participants. With this one, we are closing today's section. Still, if you have any clarifications required, you can post to me, and we will share the video and presentations also to all the participants.
Sure.
Still, we have two more sections on Thursday and Friday. Now, I am requesting Mr. Rohit to permit us to take in the separate room to interact with our students.
Okay,
Those
sure.
who are waiting for you to get your advices for their career opportunities.
Sure. Do I need to click on breakout sessions or?
Yes, you take a break of 5 minutes.
Okay.
Meanwhile, our students will join in separate room.
Okay.
We'll convey it to
Okay.
you.
Okay, then I'm hitting the close button, and in 5 minutes I'll join back in the same link. Okay.
Yes. Thank you.
Okay. Thank you, Sridhar sir, and thank you all the students. I hope I have given you some brief information regarding the current automotive trends with the EV segments. So I'll be back in 5 minutes. So I'll be open for your question sessions for your future, whatever you would like to discuss for your placements or your next career. I'm open for discussion. Thank you. Thanks a lot.
Participants, we have come to the end of day 3. feedback link has already been posted in the chat box. So kindly fill in the form and please don't forget to use your participant unique ID. We will meet again tomorrow at 10 a.m. We will have Dr. Lalit Kumar Sahu from NIT Raipur, who will be taking a session on recent trends and advancements in electric vehicle and charging station. Please join us tomorrow. I repeat, in the afternoon, we do not have any other sessions. We have come to the end of day 3. We will meet again tomorrow for the session on recent trends and advancements in EV and charging station by Dr. Lalit Kumar Sahu from National Institute of Technology, Raipur.